Hi and welcome to Maths class. Today we're looking at factorising quadratic expressions, but we're looking at a different kind of quadratic expression. So the ones we've looked at up to now follow a particular pattern, such as the difference of two squares or the perfect squares expansion. So today we're going to look at quadratic expressions that don't follow any of those patterns. So what are we looking at? Well, they're called monic trinomials. So let's look at these two terms. First of all, let's look at trinomial. Trinomial simply means there are three terms. So your difference of two squares pattern is not a trinomial, it's a binomial. On the other hand, your perfect squares expansion, this definitely is a trinomial, but it follows a particular pattern. Okay, here's another example of a trinomial. That is also a trinomial quadratic expression. Now the monic just means we don't have something like this 3 in the front. So we need a new technique when we have those, and we are going to see those later. But for now, we just have a 1 in front of the x. So you might get an x squared plus 3x plus 2. That's an example of a monic trinomial quadratic expression. So let's get started. What I want you to start by doing is just look at these examples and expand them using FOIL. None of them follow the patterns such as difference of two squares or perfect squares expansion. So use FOIL to expand them, hit pause and do them, and then come back and check your answers. So pause it now and I'm going to do my answers. Okay, so there are my answers. And you can go through yours and check them, pause if you need to, and just check your own. But what I want to talk about now is the pattern that does exist in these, even though it's a different one from the one we've seen before. And the first thing I want you to notice is that each time I have to add these two terms together, which is basically this 3 times x and then this 2 times x to get 5x. Here again, I'm going to add the 4x and the 3x, whoops, and I get 7x. Okay, so here this 12x came from adding the 5 and the 7x. And here we have 12x, which we can find by adding the 2 and the 10. Here we've got 9x, which we find by adding the 6 and the 3. And here we've got 10x, which we get by adding the 1 and the 9. Now this only works when we have monic quadratic expressions. It will not work if you've got a 2x here or a 3x here. It's simply not going to work because you'll be multiplying the 3x times this and you'll get a different number. All right, so it only works for the monic ones. But basically, this middle number here is always the sum of the second term in each bracket. Now, the other thing that we look at is the last term. The last term here is 6, which is the 2 times the 3. The last term here is 12, which is 3 times 4. The last term here is 35, which is 5 times 7. Here we've got 20, which is 2 times 10. Here we've got 18, which is 6 times 3. And here we've got 9, which is 9 times 1. Okay, so let's summarize what we've found. What is the pattern? Basically, the middle term here, this 8, is 3 plus 5. And this 15, which is the last term, is 3 times 5. So if I needed to go backwards, I need to find two numbers which add up to 8 and multiply to give me 15. Now, it may be that you think you can have a go at these now and you don't need to continue. If that's the case, have a try of a few and then skip ahead to the part of the video where we do some examples. But if you want me to take you through it really in a bit more detail, let's go through this worked example. I want to use the pattern to factorize this one. Hang on. Yeah. Okay, so I want to use the pattern to factorize this. And so what I'm going to do is I'm going to look for two numbers, because when I get those two numbers, I'm going to have x plus something and x plus something. Now, eventually we also have minuses there, but for now, let's just deal with positives. So the numbers I'm looking for are the somethings here, but I know that these two numbers are going to add to give me 7 and are going to multiply to give me 10. So pause for a minute. Think if you can think of two numbers which multiply to give me 10 and which add to give me 7. And the answer is that 5 times 2 gives me 10 and 5 plus 2 gives me 7. So this is simply x plus 5 and x plus 2, or you could write them the other way around. It doesn't matter. Let's just check it by expanding this bracket again. Now, normally I would stop here, but I can check it. If I expand this, I should get x squared plus 7x plus 10. So I get x squared plus 2x plus 5x plus 10. Now you can see that the 10 came from the 5 times 2. And I am going to get 7x because I'm going to add 2x and 5x. So I feel confident that I've got the right factorization here. Okay, so let's go through this process in a bit more detail because they're not all as straightforward. This is my technique. I want to factorize, oh, that should be squared, sorry. I want to factorize x squared plus 8x plus 12. So the first thing I'm going to do is I'm going to list the factors of 12. Now I could start listing numbers that add up to 8, but there's an infinite number of those, right? There's 4 and 4, 3 and 5, 2 and 6, 1 and 7, 0 and 8, negative 1 and 9, negative 2 and 10, negative 3 and 11. I could actually keep going forever. There's a limited, if I'm looking at whole numbers, there's a limited number of numbers which will multiply to give me 12. So let's do that. The factors of 12 are 12 and 1, 6 and 2, and 3 and 4. There's only 3 possibilities. And then I just have to check which of those pairs add up to 8. 6 and 2. Now I just write my brackets with these numbers, x plus 6 and x plus 2. And I'm done. So first I list the factors of 12, which is the constant term, the last one. Then I find the pair which add up to 8, which is the x term. It's the coefficient of the x term. And then I choose the right pair. So let's do some examples. Have a try, but if you want to just keep watching me do it, that's also fine. So I'm going to start just by listing the factors of 5. Now I love it when I get a prime number on the end because the factors of 5 are 5 and 1. Circle the pair which adds up to 6. There's only one. And then write it in brackets, x plus 5 and x plus 1. Done. All right, here's 10 again. Not again, we haven't done 10 yet. 10 times 1 will make 10. And it's really important that you remember that 10 and 1 are a factor pair of 10, and also 5 and 2. Which of these add up to 11? It's the 10 and the 1. So I write it as x plus 10 times x plus 1. All right, 12 is a little trickier because it's got a few more factor pairs. 12 times 1 makes 12, 6 times 2 makes 12, and 3 times 4 makes 12. But only one of them adds up to 7, and it's this. So I get x squared, oops, not squared, x plus 3 times x plus 4. All right, 30. How can I make 30? 30 times 1, 15 times 2, 5 times 6, and 10 times 3. I nearly missed that one, 10 times 3. Now, the only place where you might really run into trouble here is if you miss a pair. So if you've been asked to do this and you go through it, let's just say, let's just say I'd missed out the 5 and the 6, and I was looking at, so let's say I didn't do that. All right. And I was looking through it and going, oh, none of them. 30 times 1, add 30 and 1, I get 31. That's not 11. 15 and 2, that's 17, not 11. 10 and 3, that's 13, still not 11. That's a clue that I've missed a pair. So what I might do then is write a factor tree. 30 is 10 times 3, and the 10 can be broken down into 5 and 2. So I can think 30 is 5 times 2 times 3. Now I've got all of them in here, and this is the 5 times the 3, and this is the 5 times the 2, but nowhere do I have a 2 times a 3 and the 5 on its own. So that's how I might help myself to discover a missing pair if I had one. All right, this is obviously the answer because it adds up to 11. X plus 6 and x plus 5. So that's how we deal with monic trinomials when we have all positives there and when they're fairly straightforward. But this is not quite the whole picture. But the good news is it doesn't get too much more complicated, and my technique doesn't change at all. So let's have a look at some more examples. On this page, I've got some negatives here. All right. So what do? Let's start with my first example. I now see that my constant term on the end is negative 6 instead of a positive. So what are the factor pairs that can give me negative 6? Well, negative 6 times 1 can give me negative 6, or positive 6 times negative 1. Or if I'm looking at 3 and 2, it can be negative 3 and 2, or 3 and negative 2. And now I just do the same thing. Which of those factor pairs adds up to the coefficient of x? And in this case, it's a little invisible 1. We don't write 1 there, but it is 1. And this is my factor pair. 3 plus negative 2 gives me 1. If I check all of these, here I get negative 5. Here I get positive 5 when I add these numbers together. This gives me negative 1, and this gives me positive 1. So that's definitely my answer. I do the same thing, but I remember that this is 3 and this is negative 2. So x plus 3 and x minus 2. And I'm done. So let's do this one. Here I've got negative 15. So negative 15 times positive 1, or 15 times negative 1. Or it could be 3 and 5. So that's negative 3 times 5. Or 3 times negative 5. I've now listed all the factor pairs of negative 15, and I need to find out which of those pairs adds up to not 2, but negative 2, because that's what I've got here as my coefficient of x. So this adds up to negative 14, this adds up to positive 14, this adds up to positive 2, and my last, it's always the last one, isn't it? My last one adds up to negative 2. So I've got x plus 3 times x minus 5. Now these can get a lot more complicated, and as you move through some examples, you'll find that one of the things that makes it trickier is having more and more possible factors. So we love it when we get a 5 or a 7 on the end here. There's only one possibility, or 2 if it's a negative, because it can be negative 7 times 1 or 7 times negative 1. But if we have, a number like 24, there's going to be a lot more factor pairs. All right, let's do my last example here. Now this one has a positive 6 here. So I definitely want factor pairs that multiply to give me positive 6. But the other thing that's going on here is they have to add up to negative 5. So there's two possibilities. If I have two numbers multiplying to give me a positive number, either they're both positive or they're both negative. Now, if they're both positive, they're not going to add up to negative 5. So the other possibility here is for 6, I could have negative 6 and negative 1, or I could have negative 3 and negative 2. Now, if you want to, you can still list them all, 6 and 1, and 3 and 2, but I know in advance that I'm not going to need these because they will always add up to a positive number, and I'm looking for a negative number. So I'm only going to list the negative pairs. But it's really important to remember, even though we didn't look at this in our first examples, that when my last term is a plus, that can be two negative numbers multiplied together, like these. So which pair adds up to -5? It's the -3 and the -2. So my brackets are x minus 3 and x minus 2. These are pretty quick to get the hang of, so go and practice some, and that is the end of our video.